Hello. So my name is Jorge Alvarez-Solas. I'm coming from Spain, and I will be talking about the physical triggering mechanisms for Heinrich and Dansgaard-Osgood events. In the abstract I sent, I only mentioned Heinrich events, but I couldn't avoid to talk a bit on the events also. And I will take advantage of Richard's talk, because I can directly show the triggering mechanism in terms of the ice sheet dynamics. And what I'm showing here is the result of a 3D ice sheet model and the two different physical configurations, and both of them being in permanent forced with a permanent glacial climate. So what you see here on the left, and I hope this is already moving, is what Richard called a Michaelian oscillator. Okay, the idea here is what is been called the Binge-Purge mechanism, and in order to reproduce that with a 3D ice sheet model, what we have to do is impose basal velocities, because under the shallow ice approximation, the model only can treat explicitly the deformation-based flow of the ice sheet. So what we do is we add this term of the basal movement of the ice, which is proportional with an amplification factor to the surface load. And what happens is, if you saw the movie, is that you have an oscillator on the ice sheet. So basically you have a pinch phase in which the Hudson Bay is slowly growing, and until a point where the basal layer reaches the melting point. So in presence of water, this contribution becomes the predominant one, and a purge can be simulated. Now, what happens if the model is treated, let's say, on a more robust physical manner? And that would be shifting to a hybrid ice sheet model. And a hybrid ice sheet model is the one that combines shallow ice approximation with shallow self-approximation. And that means, in terms of the ice streams, that these are treated as dragging ice shelves. So we no longer impose basal velocities. What we impose is a dragging factor, which is proportional with the contrary sign to basal velocities. And what happens, and I wasn't referring on purpose on this part of the movie, even if it's freezing, I don't know that, and that's not my fault, that should be the computer. But, well, I'll put it again. What you can see here is that under the hybrid mode, nothing happens, in fact. So I have to remind that, and I agree partially with the story Richard just told. It's a beautiful story, and the trigger should be something related to the ocean that I will show now. But there's a message here, and is that when the ice streams are treated as dragging ice shelves, so in a much more robust physical manner than the shallow ice approximation, oscillations vanish. So Michaelian oscillator is no longer reproduced. So what we figured out a year ago is that if we force the model, with an oscillatory ocean, and this is an index of that oscillation in the ocean that we translate with warmer and colder temperatures, that affects this part of the ice sheet which is floating. These are the ice shelves. So these ice shelves are really susceptible to subsurface warming, to subsurface temperatures. And if we force the model with that index, what we have at the end is peaks in the Kelvin. So purges of icebergs that, if you have in mind the curve of David Hodel in 2010, you will recognize that every peak there is simulated by our model. So this is partially the same story than Richard told, with a nuance, and the nuance is that you no even need Michaelian oscillator. What you need is a model that reproduces ice shelves in the right places, subjected potentially to temperature changes in the ocean. So these are the conclusions of this first part of the talk. basically is what I just said. We could focus on the last conclusion that I'm making, is that Heinrich events are not the cause of the AMOC slowdown, but rather the consequence. And this is what David has been saying in the first talk. I didn't know he was saying that. And what I wanted to tell is that this is supported by the robustness of the physics of the ice sheet models, but also by proxies. And because proxies, what I'm telling lately is that Heinrich events occur in an already cold ocean, as David said. And in that case, the classical causality is broken. You cannot cool down the ocean with icebergs if it's already cooled down. So I just put a few sentences here that I found from Stephen Bach posted this afternoon. These are taken on purpose, and it's the same point, that Heinrich events occur in an already cold ocean. And what are the implications of this story in terms of DO events? So let's focus on that a bit. And what I'm using to focus on that is this paper, Liu et al. 2009. And why? Because it's probably the most impressive example of Hausen experiment. So you probably, all of you know this paper. What they did is they found the optimum freshwater flux forcing that allows the ocean in the model to react as the protactinium thorium predicts. And once they have found this relationship, they saw that Greenland temperatures and Antarctic temperatures follow what ice cores say very accurately. So these simulations were then applied to the whole Holocene and the rest of the deglaciation, and that has been produced in a lot of papers, a lot of impressive papers focused on different stories of the climate system. But I just wanted to take a step back and wonder, what can we learn from this Hausen experiment in terms of the DO's triggering mechanism? So in order to do that, I took the two curves in their paper. The black one is what is suggested by data, and the red one is the one they used. So I took the red one, I did the derivative, which is the freshwater flux forcing, and we forced the Climber 2 simple model, which is a 2D ocean basin model, and we forced with the same thing. And what we had is pretty the same thing, that it matches what protactinium thorium says. So a partial conclusion of that experiment would be that Hausen is the most efficient way to perturb AMOC strength. And then, because of the bipolar seesaw and other physical mechanisms being triggered, we can simulate Antarctic temperatures and Greenland temperatures mainly. But what happens if we focus now on the black curve, which is, let's say, the most realistic one? If we do the derivative of that curve, what we already see is this first peak, which is the beginning of the deglaciation, and most importantly, this second peak, which is the meltwater pulse 1A, which is concomitant with the boiling aileron. And now, if we force the simple Climber 2 model with that, what happens is this. It's a first collapse of the AMOC at the beginning of the deglaciation, a modest reactivation, and then a further collapse of the AMOC during the boiling aileron. So what's the conclusion of this? In my opinion, what this indicates is that when the model is forced by a realistic freshwater flux in the North Atlantic, it fails to match proxies. So I'd like to conclude that, and this is the topic of this session, to host or not to host, that if Hausen is seen just as putting freshwater flux in the North Atlantic, what we should remember is that the freshwater fluxes needed by the models to produce, to perturb the AMOC and to make it shift in a strong and a weak mode, conveniently do not compare satisfactorily with the timing suggested by data. So what are the alternatives then? The first one would be to consider that Hausen is still relevant, But as suggested by Richard again, the Antarctic contribution is the key, and there have been papers on that perspective. Well, the first one was more than 10 years ago, was Weaver, that showed that putting freshwater flux in Antarctica can help to make a recovery of the EMO. But more surprisingly, perhaps, is this paper of Weber, which he found IRD curves during the deglaciation, which would indicate that Antarctica is a much more reactive ice sheet than we previously thought. And there's another alternative, and it's just that freshwater flux are not important, that the reality doesn't see freshwater flux as the primary trigger of the climate system changing abruptly. And that points to other mechanisms. And a lot of other mechanisms have been suggested. I'm just pointing here a few of them. But yeah, what I wanted to remind is that we shouldn't forget this point, because otherwise we could make a false impression of understanding the system, whereas we perhaps should focus more on these alternatives. And I believe we will hear a lot of these alternatives in this session. So thank you.